Hi, I'm Mike Zaida, and today's presentation, my next column for IEEE Computer Magazine, is entitled The Invisible School According to Grok. I'm going to share the slides with you. Let's go get the slides. There's the slides, and hit these other two buttons, and away we go. And allow recording a microphone, recording a video, and let's go play the slides. All right. Share. All right. So this is the Invisible School according to Grok. Today is the 16th of September. It says 13th of September. That's when I wrote the slide. Sorry about that. And let's move on. We've got robots looking at their mobile phones and taking selfies, and robots taking video with 8mm like handheld whatever cameras. This is when you have ChatGPT, you become very dangerous with respect to art. Okay. In a past column, column number one, column from some time ago, I wrote about a project in Shanghai building the invisible school. And the question now is, can we create the invisible school using a large language model such as Grok? And in that column, I posed the question, do we need universities anymore? That was the title of the column. And in that article, I pointed out that a group of technologists in Shanghai were planning the invisible school, a school where there were no longer lectures in classrooms, but rather an online support structure that allowed students to learn things at their own speed. And figure one shows what that planned invisible school looked like when I drafted that paper. And it was no live lectures was one of the key things. There was a Genius Bar-like studio where students could be teamed up to explore knowledge. And there were different learning methods, live tutors, role-playing, cohort teaching, peer review. There was real-time updated education planning system for every student to manage their schedules, to manage their learning content. There was machine learning evaluation of students to find out what they needed to learn. Basically, all students are not alike. And it provided access, that system provided access to professionally produced master classes that provide the missing knowledge, or digital games that provide the missing knowledge, or educational artifacts that provide that knowledge. And this system had a deep understanding of every student's learning needs through big data. And the plan initially was that this was going to take a few years to launch in China. And this group is still working on this in some fashion. That project in Shanghai was focused on K through 12 education. And this column is going to focus on university education using a large language model, Grok. And the reason I've chosen Grok is the owner of Grok has expressed disdain for university education in particular, and there seems to be a significant backlash against universities in the political system of the United States. So the real question is, how close can we get to a university level education by just using a large language model like Grok's? And we're going to give it a test here. So how do I use Grok to create the invisible school? We just ask Grok, of course. If you're going to use Grok as in your invisible school, why don't you just say, ask Grok to build it for you? And the biggest assumption we have to make is that Grok has read my previous column, and we just have to give Grok the right prompt. And so here's the prompt that I gave Grok. And what you're going to see is my last name, Zaida, is highlighted when I could put a prompt to Grok. And then I took Grok's responses and I put them into PowerPoint. Grok doesn't seem to have any formatting. It just made a big mash of text that I sort of pulled out in order, and I didn't edit it, and some of it is not perfect. But anyway, so the first prompt I gave Grok was, how do I use Grok to create the invisible school as described in the Michael Zaida column entitled, Do We Need Universities Anymore, in IEEE Computer Magazine in May of 2023? And Grok came back with an answer. And I'll read that to you. The invisible school, as Zaida describes it, is a decentralized, tech-driven learning model where knowledge is shared through informal networks like online platforms, leveraging AI and digital tools to bypass traditional university structures. It's not a physical or hidden school, but a flexible virtual community of learners, mentors, and experts collaborating globally to create something like Zaida's invisible school using me, Grok. Here's how you do it. has first, second, and third choices, suggestions from Grok. First, I can help design a curriculum or learning path. You would say, Grok, create a course outline with modules, resources, and discussion prompts. I'd generate a detailed structure, complete with lesson plans or even scripts for virtual sessions. For example, I could whip up a PDF with a 10-week course in minutes. Second, use me to facilitate collaboration. You could ask Grok, draft a plan for a virtual study group on X, including guidelines for secure discussions. I'd suggest setting up a private X space or group chat for learners to share ideas with rules to keep it focused and safe, mimicking the Invisible Schools community vibe. And third, I can generate content or answer questions in real time for learners. For instance, if your group's studying quantum computing, you could ping me with explain quantum entanglement to a beginner, and I'd break it down clearly for your Invisible School members. You would host this on platforms like X. Notice X is always chosen, Discord, or a custom site, keeping it invisible by using private channels or invite-only groups. As Ida's idea emphasizes accessibility without formal gatekeeping. If you want, I can start by drafting a sample course outline or discussion plan right now. Just name the subject. Any specific topic or focus from Ida's paper you're thinking of? So Grok had read my previous column, or it read it just now. It doesn't have to have read it a long time ago, right? It could have just, once I mentioned it, it reached out and read it. And I guess Grok trained on IEEE's Computer Magazine, an additional reader I did not know about. So Grok gave me a structure for the Invisible School. Cool. But do I think it's a good idea to run discussion groups on X? No, not whatsoever. I don't use X. It's pretty much garbage as far as I can tell. How do I use Grok to create the Invisible School? This is sort of the outline in this. And these are how Grok answered me. And I've gone through that already with you. But I put it in one slide in a mind map so you can do it and remind what you read. So let's create if we've got Grok and we've got the full power of a large language model, let's create a complete university degree. Well, I wanted to test Grok a bit more. I wanted to have it think about creating a complete degree program for an undergraduate degree in artificial intelligence with a strong focus on generative AI. I need to choose a university where this degree program could reside so we could see if Grok got all the required courses and prerequisites right. So I chose the University of California, San Diego, Revelle College for this program, primarily as I attended Revelle College at UC San Diego some ages ago and have a vague memory of what courses were required. So here are my prompts and Grok's responses. So here's my prompt. Design the classes that would be in a 4-year bachelor's degree, similar to the one offered by the Revelle College at University of California, San Diego, including all the humanities and mathematics and other courses required by that school. The undergraduate degree should be in artificial intelligence with a strong focus on generative AI and its application. So Grok came back. Based on what's out there for UC San Diego, especially the Jacobs School of Engineering and related AI programs, and inspired by the liberal arts vibe of Revelle College, I've crafted a 4-year bachelor's degree in artificial intelligence with a focus on generative AI and its applications. Revelle College emphasizes a broad education, so this curriculum includes the required humanities sequence, mathematics, natural sciences, and social sciences, alongside a robust AI core. Since Revelle doesn't offer an AI degree directly, I'm modeling this on UCSD's general structure, the data science program from the Hal Xiaoglu Data Science Institute and AI courses available to undergrads with an emphasis on generative AI. It's a 180-unit program split roughly into 72 units of general education per Revelle's requirements, 108 units for the major, assuming a standard 4-year pace of 45 units per year. So this is Grok. And then Grok generated the fall, winter, spring class titles for the 4-year degree program. It built this using online real classes offered by UCSD, and Grok did fail one thing. It failed to list the foreign language requirement Revelle College has, though, and that's still in place, even though when I went there back in 1972 through 76, people were thinking about getting rid of that foreign language requirement. It has not. It's still there. And it's on the website, so Grok didn't completely read their website. Grok ends by asking me if I need more help in a very kind way. Goes, this wraps up the 180 unit degree, balancing Ravel's general education, 72 units with a 108 unit AI major, emphasizing generative AI. Want me to adjust anything or dive into a specific course? Very, very kind of Grok. Again, this is the mind map for you to know all of this in one picture. So let's ask Grok for the course syllabi. I mean, while we've got this big machine out there, let's just have it do all the work for us. We don't have to have any professors go off, 20 professors go off and generate the syllabi for 20 classes. We just could ask Grok. So I say, Grok, can you generate me complete syllabi for all of the AI courses in this degree program, including readings, content, YouTube videos that teach the material and references? Okay. And Grok responds, he goes, sure, I'll give you a concise overview of complete syllabi for all the AI-related courses in the bachelor's degree program, including readings, content, YouTube videos, and references. Since there are 9 AI-specific courses, and it lists all the numbers, I'm not going to read them to you. I'll keep each syllabus brief but detailed, covering key topics, suggested readings, YouTube videos for learning and references, and each course is a 4-unit, 10-week quarter. Perfect for UCSD, right? With weekly topics, assuming 3 hours of lecture and 1 hour of discussion per week. I'll align content with UCSD's existing AI and data science courses, emphasizing generative AI and use accessible resources. Grok, again, I'll list one syllabus fully here and summarize the rest to keep this manageable, but I can expand any if you want. Let's start with CSE 151B, Deep Learning, as a key generative AI course. Then I'll outline the others. CSE 151B, here's sort of the catalog description it gives me. Deep Learning, 3rd year, fall quarter, 4 units, description. Explores neural networks, emphasizing deep learning for generative AI, including CNNs, RNNs, and GANs for image and text applications, learning outcomes, master neural network training, and apply deep learning to generative tasks. And it gives you prerequisites of CSE and math courses. Then Grok generates a weekly breakdown of detail for the syllabus, and Grok additionally started to give me higher level descriptions of the rest of the AI courses, and figure 7 is the listing of that syllabus. I think that's coming up next. Okay, this slide again is the one summary slide. So I can get this far with Grok as I have a DSc in computer science, and so the issue then becomes, can someone with lesser technical background educate themselves completely with Grok? What were we able to do? We were able to create our plan for a 4-year AI degree from UCSD's Ravel College, including all of the undergraduate requirements. We did not need an academic advisor to plan our program. We did not need any faculty to create this. We just used the knowledge the previous faculty had created and had Grok hand it back to us. Grok just gave us the plan based on Grok's understanding of what Ravel College's course requirements are. And we were able to get pretty detailed syllabi for each class, including paper and book chapters to read and YouTube videos to watch. But I'm just going to focus on the generated syllabus for this CSE 151B course. I didn't get or need someone standing at the front of the classroom repeating the same PowerPoint slides they have been using for years, 2 hours and 40 minutes per week for 10 weeks for CSE 151B. I just must read the suggested chapters, papers, and watch the suggested YouTube videos. The big question then is, how does this way of education evaluate me as a learner? So here's the syllabus for CSE 151B, and this is the paragraph for the course catalog, which I already read to you. And then here's the weekly breakdown. Week 1, intro to neural networks content, perceptrons, activation functions, backpropagation, and it gives you some readings. Week 2, feed-forward neural networks, content, multi-layer perceptrons, gradient descent, it gives you some readings. Week 3, convolutional neural networks, content convolution, pooling, image generation basics, and then a reading material. Week 4, recurrent neural networks, content RNNs, LSTMs, text generation, Or some more reading. Week 5, generative adversarial networks, content GAN architecture, training challenges. Week 6, variational autoencoders, content VAEs for generative modeling, some reading. Week 7, training deep networks, content regularization, optimization techniques, some reading. Week 8, applications in image generation content. DC GAN, style GAN for realistic images. Week 9, text generation with deep learning content, transformers, GPT models, very important. Week 10, ethics and future of deep learning content, bias in generative models, societal impacts, and it gives you some reading. And then it just lists assessment at the bottom of this. Weekly assignments, 30%, whatever that is. Midterm, 30%. Final project, 40%. Implement a GAN or a VAE. And if you, that's all the stuff that Grok gave me. The actual UCSD syllabus for CSE 151B is here, and there's significantly less detail in that syllabus. In fact, what you'll find is it's a very lightweight syllabus, and it's got all the information about how the course is operated, but almost no content on the syllabus that's online. Again, the summary. So how does this way of education evaluate me as a learner, assuming I'm a student? And what does the Grok created syllabus say about evaluation for that course? And it goes, desired learning outcomes, master neural network training, and apply deep learning to generative tasks. And this is excellent, desired learning outcome. So how is this measured? What does Grok say? Well, Grok says course assessment, weekly assignments, 30%, midterm 30%, final project 40%, implement a GAN or a VAE. And I think this is lame, but it is what Grok gave me. I didn't ask Grok for great detail, but I thought it would do better than this. So weekly assignments is very lightweight. It's unspecified, so it can be anything. Midterm, a very old-fashioned way to assess what a student has learned. Basically, a midterm shows how well the student slept the previous night and how much anxiety they suffered preparing for the exams. And in a course like USC, that course might have 100 to 800 students in it and be taught in Bovard Auditorium. And that's really hard to give a midterm that's other than a multiple choice. All right. So not a good way to assess student learning. Final project, 40%. Implement a GAN or a variational autoencoder. And we can just ask Grok to get us the source code, right? Say, Grok, give us the source code for a VAE, and it will go off and give it to us. So this is lame. It's completely lame what Grok gave us for assessment. So a better way for assessment, and I didn't dive into great detail on this, but this is something that has to be there if the invisible school is going to work. Because in the end, we have to give the student a grade. I mean, we could give them a pass, not pass, based on the project they built, but let's think about this. A better way to do assessment is to have each student or student group propose a semester-long project to the instructor. And student groups are preferred. That's how those students will work in industry. And that's going to be a one-person group for the most part. With semester-long projects, we have the students do a live demo at midterm, and on the last day of class, we do a demo day, which is very exciting. Gets all the students to remember what the course is about fondly, and it gives them something to put on their resume, right? Because they've built this project. We have the students write a technical paper on what was achieved and provide a YouTube video of the presentation of the developed project. Again, YouTube video is where a lot of people are looking for educational information now. So this is key. Grok and probably all large language models have no ability to understand what the best way is to evaluate a student in class. I do not know what happens if we provide the student technical paper and final YouTube video to Grok to provide us an assessment and a student final grade. For the invisible school to work, Grok must do that analysis, and we have to have a live professor, instructor, TA to develop a parallel assessment for a few years to see if what Grok does for assessment matches what we believe to be correct. So imagine that we're going to have professors detail how they arrived at the grade for each student, and then hand that assessment off to Grok to learn so that it can grade students in the future in the same way as those professors came up with. And I'm not sure this is going to work, though, because the real thing with assessment for classes, if you're trying to give them multiple choice tests, that's probably really easy to do an assessment. But if they're doing a project, you want to probably just give an A, B, or incomplete, right? A is fantastic project, B is okay project, and incomplete because they didn't do enough work, right? That's kind of what I think the answer is. But to have professors detail how they arrived at a grade, I don't think that's going to work anytime soon. So references, here's one reference to my own paper, Do We Need Universities Anymore? IEEE Computer, the games column number 11, May 2023, some time ago. We are now in 2025. It's like 2.5 years ago almost. Acknowledgements. The author wishes to acknowledge those readers who have gotten to this end of this bi-monthly column without finding all of the deliberate and accidental errors. And I apologize for my personal commentaries, but I think they're very important for our futures. And the Invisible School is most definitely part of our future. All right. Anyway, if you have questions, here's my email, here's my website. If you're on WeChat, here you are. All right. Let's exit from screen sharing, and I'm back here. And I wish you a very wonderful day. And I hope you have enjoyed this column turned into YouTube video. Now the column is no longer just the games column. Now the column at IEEE Computer is now called the Games, Film, and Generative AI column. It's a very broad focus because that's sort of the focus I've been on the last couple of years in the IEEE Computer column space. Anyway, have a great day. And what I'm going to do is stop recording now. Bye-bye.